Pi Day. So, Pi Day, right? March. I know it's kind of dumb. March 14th in USA date format. That's 3/14/2023. And that's pi. Pi is 3. Blah, blah, blah. Okay, you get that. But did you know the connection between pi and g? So g is the gravitational field on the surface of the Earth, 9.8. So let's take this. The square root of g equals. So let's do that with the calculator right here. So I'm going to use 9.81 for g, although there's no great number. Let's see, put it right here so you can see. Square root 9.81 equals 3.13. So 3.13, which is approximately equal to pi. So it's a very close approximation, and it's not random. There's a reason for that. And it has to do with pendulums. So let's start with the pendulum. So here's my mass on a string. If I pull it off to some angle like that and let it swing back and forth, it has a length L, then I get a period T equals 2 pi, the square root of L over G. I mean, we can derive that, and I've done it before. It's not a big deal. I mean, it's actually kind of complicated, but that's fine. We see this in physics all the time. So that's the length of the pendulum, and G is the gravitational field. So it turns out that this was used for it's called a seconds pendulum. And that's one in which the mass goes from one side all the way over to there and back in 2 seconds. So it takes 1 second to go across. So t is 2 seconds. And if I put t as 2 seconds, then I get this is the 2 times pi times the square root of L over G. And if I put L equals 1 meter, then that cancels, and I get the square root of G equals pi. And so that's where it comes from. It comes from one of the definitions of a meter. So this is how you could define a meter. But of course, this is not a great way to define a meter by using a seconds pendulum. Because if you go around the Earth, I mean, G is not constant. G depends on the density of the stuff around you. It depends on the location of the Earth, because the one that you're measuring is actually the effective G. If the Earth's rotating and you're at the equator, then your G value is going to be less than at the North Pole because of this, you could say centrifugal force. I'm going to say centrifugal force. So that matters right there. Also, if there's like a large mountain, and you hang a pendulum, you think it's vertical, it's actually going to be deflected and pointing a little bit towards the mountain. So there's a whole bunch of things that make this seconds pendulum not the best way to define a meter. So a couple other ways I think they did, another way to define the meter was to find the distance from the North Pole to the equator, and I think that was 10 million meters. And you go through Paris. But that seems kind of silly too. Finally, there's another way to say, this is what we use now, C equals delta X over delta T. So if this is the speed of light, and this is some known time interval in seconds, then that would be a meter. So it's based on the speed of light, and that's what we do right now. But if you take the square root of G, you get it very close to pi, and that's because of the way we define a meter. One of the earlier definitions of the definition of meter. Happy Pi Day, the end.